The next thing we want to look at are complex numbers. And again, we want to see how they relate to trig, or how trig is used to deal with complex numbers. You, at some point along the way, have probably been introduced to the imaginary number I. And I is the square root of -1. Now, we know that in the real numbers, you can't take the square root of a negative, because the square root, you're asking what times itself equals that number, and nothing times itself is a negative. So technically, in the real numbers, these don't exist, but they show up in real-world situations. They show up in engineering. They show up in things that needed some way to deal with them. So they came up with the number I, and I is the square root of -1. And just as a review, the way you would do this, if you had the square root of -4, this is the square root of 4 times -1, right? We could factor that. We could split that up. The square root of 4 times the square root of -1. The square root of 4 is 2. The square root of -1 is 2i. So the square root of -4 is 2i. Now, complex numbers means you take that imaginary number and you just put a real part with it. So a plus bi is a complex number. A is the real part, and b is the imaginary part. So 2 plus 3i, that's a complex number. It's got a real part, it's got an imaginary part. 1 minus I is a complex number. Even what we wrote up there, 2i, that is a complex number, because we could say 0 plus 2i, right? 0 would be the real number, 2i is the imaginary number. Now, the way we have written it, and if you have dealt with complex numbers before, this is the way you've dealt with them. That is called the rectangular form. And what we're going to do next is learn how to change this rectangular form to the polar form. We talked about polar form in the last video on vectors. We're going to do the same thing with complex numbers. We're going to go back and forth between rectangular form and polar form. Now, to get the polar form, if I start with a plus bi, okay, the way you graph a complex number is you put a as the x-coordinate and b as the y-coordinate, okay? So this right here is your x-coordinate. The coefficient of I is your y-coordinate. So that gives you the right triangle we've been looking at the whole term, and then r there would be the hypotenuse, right? And we're also going to need, since we're dealing with polar form, we're going to need an angle, okay? We need a hypotenuse or a length there, and we need the angle. And we start with a plus bi. Now, if you will notice, a, b, and r would all be related around this angle theta, right? We could say that the sine of theta is b over r, right? And we could do that and we could solve for b. The cosine of theta is a over r. We could do some algebra and we could isolate a. I'm not going to do all that in this video. I'm going to show you what you get. If you want to see how it works or why this is, be sure to ask me. It's also in your textbook. But I'm just going to save time and to not muddy things up too much, I'm just going to tell you what this is. If you were to do the trig over here and solve for a and solve for b and then do a little bit of algebraic manipulation, you would get that this is r, that's the length of that hypotenuse, times cosine theta plus I times sine theta, okay? Now, this comes up over and over again. This is polar form. There's shorthand for it. This is r, and instead of cosine theta plus I sine theta, what they're going to write is CIS theta, okay? And that is r times cosine plus I times sine theta. That's the shorthand for it. So, for example, what polar form is going to look like is 3 CIS, and let's put an angle in there, 15 degrees. And what that means is 3 times the cosine of 15 degrees plus I times the sine of 15 degrees. So this would be the long way to write it. This is the shorthand, okay? We're going to learn how to go from polar to rectangular form. So the first thing they give us a complex number here. Root 2 plus 3i is a complex number. And we're going to write that in polar form. Here's how we do it. We're going to graph it. If we have root 2 plus 3i, we graph the coordinates root 2 and 3. Okay? So that's in the first quadrant. This would be root 2. This would be 3. We need r and we need theta, right? Well, the first thing we're going to do is Pythagorean Theorem to find r. So we're going to say 3 squared plus the square root of 2 squared is r squared. So that's 9 plus 2. And we're going to get r is the square root of 11. Okay, r is the square root of 11. Then, now it does say to round there. I'm just going to leave that that root 11 because it's going to be not a lot neater than a decimal. The next thing we need to do is to find theta. Well, we could use the hypotenuse, but we may have made a mistake there. So I'm going to use the two sides they gave me. They gave me the opposite, they gave me the adjacent. So I'm going to use the tangent ratio to find theta. So I'm going to say the tangent of theta is 3 over root 2. This is where I'm going to start rounding a little bit. 3 over root 2 is 2.1213. Then I'm going to do my inverse tangent, and I get that angle is about 64.8 degrees. So the way this would be written in polar form is r, which is root 11, times CIS, which is cosine theta, plus I times the sine of theta, and theta is 64.8 degrees. That's the shorthand. If we were writing it out, it would be cosine 64.8 degrees plus I times the sine of 64.8 degrees. I've always said mathematicians are lazy people. They'd rather write it this way than write this out every time. All right, next one, 1 minus root 3i. That means we're going to graph the coordinates 1, negative root 3. So that is in the fourth quadrant. This would be 1. This would be negative root 3. And what you should see here, now this would also work. This would not be bad to do Pythagorean Theorem because you'd get something exact. This is a 30-60 triangle, right? This is going to be what's across from the root 3. This is actually the 60-degree angle, right? This would be the 30-degree angle, which makes our hypotenuse 2, okay? And I know you can't tell at all what I wrote right there. Let me do that a little bigger. If this is 1 and this is negative root 3, that's supposed to be a right angle. This would be the 30-degree side. This would be the 60-degree side. And then the hypotenuse would be 2. It'd be double the 30-degree side. This is still be okay, Pythagorean Theorem, because you're going to get 2 when you solve that. But now that we know that the reference angle is 60, how many degrees is it around? Well, that'd be 360 minus 60, which would be 300 degrees, right? My reference angle is 60 degrees, and theta would be 300 degrees. So the way I would write it, I'd write r, which is 2, that's that hypotenuse, CIS, 330 degrees, okay? All right, so that's how to go from rectangular to polar form. Now let's look at the other way. Going from polar form to rectangular form is actually not too bad. It's going to be mostly calculator work. You do need to look and see if you're looking at a unit circle angle. If I look at 20 degrees, 20 degrees is not a unit circle angle, right? So 5 CIS 20 degrees is actually 5 times the cosine of 20 degrees plus I times the sine of 20 degrees. To get to rectangular form, you do need to write it out the long way, okay? Because now you're going to do your calculator work. The cosine of 20 degrees is about 0.9397 plus I times the sine of 20 degrees is approximately 0.3420, okay? Then you're going to distribute this 5, and you're going to get 4.7 plus 1.7i. Check my calculations, make sure I didn't mess anything up. But I did 5 times 0.9397, I got 4.7. I did 5 times 0.3420, and then the I sort of tags along. Okay, this next one, same thing. Where is 210 degrees? Well, 210 degrees is in the third quadrant. Does it have anything to do with a unit circle angle? Well, it does, doesn't it? Because this is 180 degrees, and then this right here would be how much? 30 degrees, right? So we're looking at a unit circle angle, so we need exact measurements. Well, the 30 side is how much of the hypotenuse? Half of it, right? So half of 4 is 2, but it's negative 2 because it's going down. And then the 60 side would be negative 2 root 3, also negative because it's going to the left, okay? So now what we need is to write this out longhand. This is 4 times the cosine of 210 degrees plus I times the sine of 210 degrees. And we're going to use the little triangle that we just wrote right there. So this is 4. The cosine of 210 degrees, this is negative. Everything's negative but tangent in the third quadrant. So the cosine is negative 2 root 3 over 4. That's my adjacent. Over hypotenuse, plus I times the sine, which is negative 2 over 4, okay? Now, when I distribute here, the 4's are going to cancel, so I'm left with negative 2 root 3 minus 2i, okay? This 4 canceled with this 4, and I was left with a negative 2 root 3. This 4 canceled with this 4, I was left with a negative 2, and you write it first, you write the I at the end. So not too bad. Needed to know that it was a unit circle angle so that we got exact answers and not decimals.